Hi, I'm Midunya. I'm telling you about data analysis. I have a dataset in placement data. Import pandas as PD. Pandas is a library commonly used PD. Dataset equal to pd.read.csv placement.csv. PD library to read a CSV file. Check the null and none values. Dataset dot is null dot sum. Check the missing values and replacing the missing values. Salary column have a 67 none values. Methods of replacing the none values. First one, replacing the missing values with central tendency, mean, median, mode. Mean is the average value of the column. Median is a midpoint of entire column. Mode is a mostly repeated value in the column. Second, entire row delete. You can choose to remove the row to loss of data in a dataset. Third one, respective to the problem statement, have to replace the missing values. You have a specific value should be used to replace the missing values. Fourth one, consider this as semi-supervised, create a model so that we can predict the missing values. It is a semi-supervised learning program. Only a small portion missing values. This model approach. So I can choose a third model. Next is dot filna 0 in place equal to true. A filna function will change the value of 0 in the missing value, and then in place equal to true function change directly the original dataset. Dataset dot is null dot sum to check the replace missing values in the dataset. None value replace the value of 0. How many of them are not placed? Print dataset status dot value counts not placed. Not placed is a categorical data in the status column. Run this code. The count of not placed students' data are displayed. 67 students are not placed. Next, find the reason for non-placement from the dataset. Dataset table, dataset status equal to not placed. Not placed students columns only displayed in the dataset. Only not placed data. Next one, dataset degree test dot d type. The data type identify the degree test. Degree test is the categorical data. So this is a object like text or string data. Next one, def qual quant dataset. Qual is qualitative data and quantitative data. Qual and quantitative data upon the variance, qual and quant variance. One dataset, it's also upon to the qual and quant variance. Identify the qual and quant dataset in placed students. Calculate the median and the average of 10th mark 72.5, 12th 68, degree pass mark 68, entrance pass mark 72, and then not placed students average mark 10th 67, 12th pass mark 65, degree pass mark 66, entrance pass mark 71. Not placed and placed students difference in the entrance pass mark. Placed students average pass mark 72%, not placed 71. So average reason for not placed students get below the 72%. Next, what kind of relation between salary and MBA? Dataset dot correlation. The relationship between salary and MBA can calculate the correlation between these two variables using the correlation functions. Salary and MBA is correlation between 13%. Placed students in the dataset. Salary in ascending order from the row with lowest salary. And the minimum salary is 2 lakh. MKT, market and HR and marketing and finance specialization getting minimum salary. The analysis of variance between entrance pass mark and MBA pass mark at significance level of 5. Importance level of 5, the p-value is 4.6. See, above the 0.5 percentage, so accept the null hypothesis. There is no significant difference between two columns. Reject the H1 alternative hypothesis. There is significant difference between the two columns. Test the similarity between the degree test and specialization with respect to salary at significance level of 5. Now, first calculate the mean and standard deviation of the salary column. Z score can be calculated. Plot the Z score as a standardized distribution. Standard distribution. KD equal to true is a display the curve. Plot the Z score as a standardized distribution. Standard distribution. KD equal to true is a display the curve. Next, standard normal distribution graph. A data set salary column can create a plot. This is a salary plot. What is the probability density function of the salary range from 7 lakh to 9 lakh? Def get the PDF probability dataset start range in range. Calculate PDF which is specified salary range using for normal distribution. Next, form the start range. The start and the end range of line is red color. Next, sample equal to data set. Sample mean equal to sample dot mean. Sample standard equal to sample dot standard. It calculate a mean and standard value of data set. Next, generate a list of values. List PDF value is the probability within the range. Next, calculate and total probability within the specified range. Get the graph. Get PDF probability data set, the salary range, specified range in 7 lakh to 9 lakh. The test similarity between the degree test with respect to the entrance test and the MBA pass mark at a significant level of 5, making make decision using hypothesis testing. From CP dot states import t test rel, import the t test function from the CP state. Dataset equal to dataset dot drop now. It's dropped values in missing values. Dropped in missing values. Degree equal to dataset table. Dataset degree test equal to science and technology entrance pass mark. And degree 1 equal to dataset degree test equal to science and technology MBA pass mark. Created two variables, degree and degree 1. Apply the parity test to compare the two columns in related samples. So check the p-value. P-value is 5.51. It's a greater 0.05 percentage. So accept the null hypothesis, and there is no significant similarity between E test entrance test pass mark and MBA pass mark. Each parameter is highly correlated with salary. Data set dot correlate for it's correlated by salary and all numeric columns. A high for a high positive correlation related to the salary. The high parameter is 10th pass mark 0.53. 10 SSC pass mark is highly correlated with salary. Plot any useful graph and expand it. Import C1 as SNS dot path library imported based on matplotlib. Plotting is pair-based relationship, and the columns and row is multiple axes. Is the perfect positive correlation. The independent variable and variable is directly proportional to dependent variable or equal to 1. This is the high degree of correlation. Um, this also this is no correlation. This and this also no correlation. Okay, that's all, friends. Thank you.